Hi. So, thanks for that introduction. It's good to be here, and I'm glad to see you here. So, I'd like to act as a kind of messenger for some of the great developments that have been happening in Python for science and engineering applications. And there have been a lot of very exciting things happening, particularly in the last 12 months. So, I thought I'd like to make this an update of what's new. So, could I ask for a show of hands of people who have used NumPy before? Okay, and who has used IPython before? Okay, great. And who has used pandas before? Okay, good. All right, so, all right. With that, so here's the structure I'd like to have for this. So a brief introduction, and then a little overview of the ecosystem for those who aren't familiar with it. And then I'd like to show some demos of IPython and the IPython notebook interface, and give some summaries from, of the sort of latest development and of the SciPy conference that happened last month. And then I'd like to introduce Pandas for those who don't know about it. And this is a great tool that's just come from nowhere in the last 12 months. And now it's giving R a run for its money with data analysis and modeling, and that's really great. And then I'd like to sort of touch on the topic of Python 3 compatibility and show you what is possible today with Python 3 with scientific and engineering tools. Okay, so a brief intro. How I found Python is, so I was doing computer science research in pattern recognition, in speech and image recognition technology, and I found I needed good tools for that work, and that had to be somewhat cross-disciplinary. So any of these tools that I tried to use, so C++, MATLAB, Java, and so on, they were all too clunky or too specialized and not general enough. So I discovered Python, and I haven't used any other programming languages since then. So I did my research work using it, and I started contributing to NumPy and SciPy because back then, it was a lot more primitive than it is now. So now there's an amazing community. Back then, it was kind of very, very much smaller than it is now. And back then, there was actually a split between numeric and numarray. And so the NumPy package that we have today didn't exist. And that was really slowing down the adoption of Python in scientific circles for that reason. But Travis Oliphant was the one who kind of took the lead with that, and he did a great job. So anyway, I got involved with that. And so a little bit about Python Charmers, who we are. So we offer specialist sort of Python training courses in the Asia-Pacific region, and we offer courses for programmers, and but particularly for different kinds of scientists and engineers. So there are some for geosciences and some for bioinformatics and financial engineering and so on. And what we tend to do is to bring in specialists in each of these topics for the training. So if you're interested in anything like that, then let me know, either from the side of taking a course or from the side of potentially giving a course in one of these specialized disciplines as well. So I'd like to say thanks briefly to DH, Daehyok Shin, and Kostya Belitsky, and Nathan Fajian. They contributed some of the examples that I'll be presenting. So now a brief overview of the scientific Python ecosystem. I suppose a good place to start is with the conferences. So there are two major conferences each year. One's in America, the SciPy one, that's in Austin, Texas currently. And there's one in, it chops around between different European countries, but it's sort of, the Euro SciPy conference is happening again. It's in about, I think it's next week. And the SciPy conference was just last month. So there's a lot of interesting work being published and discussed right now. So here's a photo. It's a little bit old. It's of the SciPy conference in, so I think it was last year. The community is very large nowadays. And it's very interesting. There are over 1 million unique visitors to the scipy.org website now each year. And that's very impressive. Also, the new Pandas package is it's now had 100,000 downloads from PyPy in just the last 12 months. So here are some of the packages in use, and NumPy acts as the kind of foundation, providing a basic array infrastructure. And then there are various others that make use of that. So NumPy itself is quite a low-level tool. Nowadays, a few years ago, it was quite a high-level tool in some ways. But now there are many others that build on top of it, and I'll be presenting a couple of those today. This slide just gives one perspective on the history of scientific computing, from a focus on raw computational efficiency a few decades ago to a focus on programmer efficiency and ease. And now that's sort of increasing, and now there's more in the way of interactivity and visualization. And the future, perhaps, is with open source high-level languages. So at the SciPy conference, it seems there was quite a focus on Python as superglue for a variety of interesting tools. Here are some of the sort of themes at the moment in scientific and engineering uses of Python. So high-performance computing is a big deal, particularly with CPUs growing. With a sort of parallelism in CPUs nowadays. And there's the question of what tools can make use of that. And Number, I'll just mention, is something that Travis Oliphant presented at SciPy. It's still at the research project stage, perhaps, but the goal of it is to take the high-level information in NumPy code and to act as a translator to this low-level virtual machine bytecode, so that can be compiled on the fly, so using type inference. And type inference is sometimes hard and sometimes easy. The goal for Number, I think, is just to tackle the easier problems first. So it should act as a sort of, as a way of really speeding up code without trying. There are various other tools as well. The IPython notebook is very cool. So for those who haven't seen that, I'll be demonstrating that today. And Pandas is a very useful tool as well. So I'll just mention these as well. So if you're interested in up-to-date information, there are videos of the SciPy conference last month. They're online now, as of about a week ago. And the Euro SciPy conference will be in about, well, that's sort of next week. So now I'd like to introduce IPython for those who aren't aware of it, and for those who are, also show you what's new with it and what you can do with it now. First of all, the goals are very ambitious, actually. The goals for the IPython project are to streamline the entire scientific workflow. And there's this idea of executable publications, which should lead to more reproducible scientific results, particularly if notebooks can be shared on the cloud, and people can collaborate on those as well. So this idea of executable publications. So to make that possible, the IPython notebook handles very rich display of objects, and I'll give some examples of that. And one of the latest features, which hasn't yet really hit the, I don't think it's in the Git repo yet either, but Fernando Perez, the kind of lead for the IPython project, he was hacking on it around the time of the SciPy conference, and he showed a little demo at that conference. So so one of the features it has is integrated MathJax. So who's heard of MathJax? It's a brilliant JavaScript library that can render LaTeX code in the browser. And it does so very, very well. And the goal for it is to work across all browsers. So there's a little example, some text source, and that will render to that. So I'll give you some examples of that too. So this is this idea of PDF output from IPython notebooks. And the idea is that that it'll be possible to just produce a PDF version of a paper directly from the notebook without editing anything. So completely automatic translation from that notebook to that static publication. So that's very interesting, including all of the equations and graphics and everything. So to make this possible, the IPython project has undergone quite a serious restructuring in the last few years. And now there's a kernel which runs sort of this client-server sort of relationship. And you can have multiple clients, each connecting to this IPython kernel. And I'll give some demos of the interface with SymPy using that MathJax interface, and the interface with R. And in line with the pirate theme from this morning, I've got this flag here, and there's this this quote I thought I'd share with you, which is, "To err is human, and to R is pirate." So, so I thought that was good. So I'll demonstrate that. Yeah. Okay. All right, so here's the IPython notebook running in this Ubuntu virtual machine here. So I've got a few here that I'll show you. So the idea is it's in a web browser, for those who haven't seen it. So this is, you can invoke this from the terminal by typing IPython notebook. And you can run, edit code. There's also documentation, so this is Markdown. You can format it as well. And you run this, Pylab inline. Now that invokes matplotlib, and that now allows you to plot figures inside the browser. And so I'm going to run that, and run that little for loop. And there I've got my plot from matplotlib. And one of the new features just in the last few months, you can actually resize these as well.
I think you just blinded.
Yeah. Yeah. Yeah, this is a really brilliant project, and yeah, they've been doing amazing work with this. So you can export these too, download the Python script, or you can just print it from the browser into a PDF or whatever. So it's really great. So now here's a little example with Monte Carlo simulation, so something that might be useful. So in this case, it's just estimating pi. It's using a generator. Okay. So there's this little generator, and I'm going to run it now 50 times, and there's the plot. So I can kind of analyze convergence behavior, and I should see it starting to converge on 3.14 before long. So if I run it for 10,000 iterations now, okay, I'm going to actually time that, see how long that takes. So this %timeit command, for those who don't know, this is an IPython command. This will run that piece of code as many times as it needs to get an accurate estimate of how long that took. So in this case, 600 or so microseconds per loop, so it's very fast. So I'm going to just go back and edit that now. So it's nice that you can just change code. So it's unlike a sort of standard terminal, it doesn't just keep scrolling up. You can go back and edit and then just rerun it, which is great for exploratory data analysis. Okay, a couple of little image smoothing examples. I gave some of these last year, but the IPython notebook hadn't really been announced yet, and it wasn't yet officially released at this time of this conference last year. So I gave these examples without it, but I'll just show you that. So this is an example of just sort of denoising using convolution, and you can see the results of this filtering in the browser like that, and that's quite nice. I've got a couple of other little image reconstruction examples too. So here's one, the original image. I corrupt it with random noise, white noise, and now if I want to use the signal processing package in SciPy, and this Vena function there, I can reconstruct that. So that's that's better than the noisy version. So yeah, it's nice. I guess this is a demo of a couple of things, but it's just sort of what's possible with this. So if we have time later, I'll come back and show you some of these others. There's this, yeah, that's fine. All right. So, okay. So the next thing I'd like to show you is animation. So it supports primitive animation. It's not as good as something like Chaco, a dedicated sort of animated plotting package, but it's okay for some purposes. So here's a little example of how you do this in a browser. See that number's changing from 0 up to 9 there. So you can have sort of simple indications of progress in the browser like that. And here's a plotting example. So I'm going to run that. There we go. So adding more Bessel functions there to that plot. So yeah, you can do things like this. I thought I'd show you this as well. You can embed YouTube videos, and I found this skateboarding dog, which I thought was really amazing. So so I'll see if that works. There we go. I thought I'd show you this skateboarding dog. It's just cool. So you can just you embed MPEG-4 videos as well directly in your scientific publication. So, very scientific indeed, isn't it? Yeah. All right. Okay, there we go. So I better stop that, or it'll make my computer whir with the fan. Okay. All right. So now SymPy. So SymPy is the sort of open source symbolic maths toolkit, so otherwise known as homework solving. I don't know what the teenagers of today do with their maths homework, but they would probably get pretty far with something like this. I'll just show you this. See the double percent sign? That's this sort of cell magic command that IPython offers for embedded LaTeX. So you just have some LaTeX code, and oh, okay, so that didn't work. I need to run that. And it's got this load extension SymPy printing. And I'll try that again. Okay, that's not working for me right now. Oh, sorry about that. Maybe it was my skateboarding dog that's kind of destabilized the kernel or something like that. I'll try to restart it. Yeah, this is nice. So if you've got a process that crashes, like if you've got Cython code, which is doing something nasty and causing a seg fault, and then you can restart your kernel from the browser like this. And so I'll try that once more. There we go. And that. No, okay, that's not coming up right now. Oh well. So is this going to work? Yeah, that's good. So this is, yeah, you can define these things, and now I'll just expand that. Boom. So that's SymPy, and this is showing the integration between SymPy and the IPython notebook here. So see what this is. This is an image. Just like, well, I guess it's simpler than that YouTube video, but it's an image. So there's this generalization of a concept of the representation of a Python object to images, to web pages you can embed inside, and so on. Okay. Other things like this, and I'll simplify that. Yeah, so it's, yeah, that's right. I'm going to solve it. I get my roots. So this is another amazing tool, and the integration is so slick between IPython and SymPy now. I'll just show you some other things here. So limits and Taylor series expansions, symbolic differentiation here, whoop, and symbolic integration. And now, yeah, so there's this Taylor series example. So some of these are sort of based on example IPython notebooks that come with IPython now. This Taylor series is like that. So it's a rather long function, but I'll run it, and I'll show you the sorts of things you can do. So yeah, for kind of comparing different Taylor series expansions, that sort of thing. So it makes our analysis quite easy nowadays. Yeah, so all right, one more. Just to, yeah, you can sort of analyze the behavior there. So really, it's really pretty easy. Okay. So the next thing I'd like to show you is the integration with R. That's this R magic. So it's this load ext R magic. Now this is so with any luck in the future we won't be needing to use R because tools like pandas will just keep getting better and better. But there is a great wealth of statistical functions that are being written in R so that we can make use of with this tool RPy. So this sort of shows the interface. By the way, this is RPy, last I checked, it's completely impossible to install on Windows, so I wouldn't even try. But it works with a couple of versions late, yeah. Major versions, I think, even. Right, yeah. All right, yeah. Yeah, stay tuned for the talk on RPy later, yeah. Okay, so some examples of the integration there. So this result, yeah, so it's come from, this is, so yeah, just checking, so yeah, running this R code and checking that it's the same as the Python code here. And I thought I'd show you this other thing here as well, precision 1. You can set the precision like that in IPython, which is quite nice. So if you're used to, if you don't want to have this anymore, you can just use this magic precision command, and it'll give you a different number of decimal places. Okay, so yeah, you can capture plots from R as well. So there's an R plot, just in the browser too. Cell level magic. This is saying yeah, the rest of these are R commands it's going to issue. So it runs those, and there's the R plots. So yeah, now the rest of it is, I won't go into that. Essentially, the way to get R data frames into Python now is through NumPy structured arrays, and it's okay. It's a little bit clunky, and in the future, Pandas is going to make well, this easier. So things, these structured array, so R data frames are going to come straight in as Pandas data frames. So I'll show you what I mean by that when I come to Pandas next. One other thing though first, who's used Cython? Okay, not as many people. So Cython is it's a hybrid between C or C++ and Python, and it allows you to statically declare the types of some variables in order to get little speed ups, and it sort of calls your C compiler in line. So now IPython Notebook can actually do this for us. So so I can run this sort of thing in Cython. Now here's an example of where some of these are, the types are declared. Okay, double, see this? It's a function, it looks like Python, but it's got these variables are declared as doubles here. So, so in any case, this will run a lot faster than the equivalent Python version would in that loop. And if I run that there, and there's this time it function again, I can just see how long that takes. There we go. So it's, yeah. So this is nice. For those who use Cython, it's becoming easier and easier. So what this is actually doing is actually compiling this code, translating the Python code to C, compiling the C code, and pulling it in and calling it. So that's all going on under the hood just when I press Shift Enter there. Okay. So the next topic here is Pandas. How am I doing for time? It's 1:36, that's 25. Okay, we've got about 15 minutes left. All right, so yeah, this is a great tool now. It's really come from nowhere. It's so there have been 5 major releases in the last 12 months. Really rapid development, and now there are well, there have been 65 committers in that time. 12 months ago, there was only just really Wes McKinney, I think. Yeah, so just in the last few months, the main focus has been on overhauling time series, because did anyone use the scikit.time series package? Okay, only one person, I think. Yeah, that's now been declared defunct, and the functionality is being merged into pandas for those who want to manipulate time series data. So that makes use of this datetime64 object, which is in NumPy 1.7. Now Ubuntu 12.04, the long-term support release that's come out recently, that doesn't have NumPy 1.7. So it's going to be interesting to see how Ubuntu users can install the latest version of Pandas. But it does include 1.6.1, I think. So with any luck, that'll be okay. But it's probably a better idea for time series users to install the latest NumPy by hand. So I'll show you some demos of our pandas now. So just some simple ones to start off with. The Olympic medal table. This is fun. So this, I found a spreadsheet on a New Zealand government website, which showed the Olympic medal tally and population, and compared them. And so I kind of doctored this, and I've got this CSV file now, which is just the essentials. So I'll read that in. So notice you can read that CSV with just one line, and it comes in like this. So now this is a data frame in Pandas. So it shows us that we've got 1, 2, 3, 4, 5 columns, and 204 countries. And I'm going to print that now as a string. So there we go. That's the population in millions, and the first number is the number of gold medals. There you go, gold, silver, bronze, and total. Okay. So now what I thought I'd do is plot the which countries were the most successful by head of population. And so if we look at gold medals, we can do this kind of thing in Pandas. So medals gold. Now that is going to pluck out the gold column. Okay, so it's like the NumPy record array interface, or sort of structured array interface, but it's nicer. It's at a higher level. So in any case, I'm going to run that, and I'll just filter it to make it plottable. And now that's a bar plot there. So Jamaica's got the most. No, is that Grenada? Grenada, yeah. And Jamaica is down there. So what's that? Bahamas in second place. Yeah. So that's interesting. And so where's New Zealand on that list? It's number 4, I think. And we don't. Yeah. Anyway. Yeah. So
more important
if we.
New Zealand came 4th.
Yeah. If we change that now from gold to total, so we do a bit better, and I'll plot that. So Jamaica's now way. Oh no, Grenada again. Is that right? Okay.
Well, that's right. They've got no population.
Yeah. Yeah. Right. That's true. Yeah. There we go. Okay. So. Yeah, that's pretty good. So another feature of this IPython notebook, it's in the Git repo now. I thought I pulled a version that is supposed to work. It crashes for me currently, but the feature is that you can, in theory, you can now switch between different Matplotlib backends. So I just had that popping up as a WX window. I could equally well now do Pylab inline, if it were working, and it will be soon. And then I could replot that as an inline plot. Okay, but it's not working at the moment. But but that will be possible soon to switch between those backends. Okay, so a bit more about pandas now. This is just giving a few other examples of what it's all about. Okay, so there's this concept, columns and indices. There we go. I'll just show you a couple of things you can do with it. So pivot tables work pretty well, hierarchical indexing. Yeah, there's this good group by functionality is being rewritten. And it's now very, very strong, I believe. And you can have these nice sort of box plots generated very easily from your data frames. So that's definitely a good tool to watch. Okay, okay, now just a few words on. Okay, thanks. A few words on Python 3 adoption. Who uses Python 3? Okay, one person, and a couple of. All right. Yeah. Okay. Okay. So Python 3.3 is going to be released pretty soon, and it's probably going to be. It's going to speed up adoption because it's got some nice features. So I thought I'd just give you a couple of comments on migration in general. So NumPy has great Python 3 support, and it has had for 2 years now. So that's really good. And I'll show you these running. So SciPy also supports Python 3 as of version 0.9, I think. And Matplotlib does as well. So originally it was a separate branch on GitHub, and it's been merged back into the main branch now. So I was able to get Matplotlib working in Python 3 just by recompiling from source, and there were no other tricks. It was a pretty straightforward process. So I'll demonstrate with Ubuntu. So Ubuntu actually comes with that is the latest version, comes with packages for so Python 3 versions of IPython and NumPy and SciPy. So I'll show you this running. I'm going to run IPython 3 Qt console and just show you this. So I've got it now. If you haven't seen this, by the way, this is a sort of better IPython that in some ways. So it's got like syntax highlighting and these little pop-up help windows and things like that, and proper multi-line editing, which is good. So I'll just show you, because this is Python 3, that is going to give me a syntax error. So this really is the latest and greatest. Yeah. What I wanted to show you was, I'll try that, PyLab inline again, and see what we can do here. I'm going to do plot rand 100. There we go. Okay, so that's IPython and Matplotlib running on the Python 3 there. So that's pretty good, and SciPy works too. I'll show you the version. No, version is there. The file is there. So it's been installed there into that Python 3 directory. So these basic packages are in Ubuntu, which is great. A good start. I'm just going to give you some other demos of that. Yeah, that's okay. So there were some other things. Okay, 5 minutes, thanks. Right. I thought since we've got a couple of minutes left, I might show you Chaco. Who's used Chaco? Okay, hardly anyone. So Chaco is a package for interactive plotting. It's not nearly as widely used as Matplotlib, but it's got some nice features. So I thought I'd just demonstrate a couple of little examples with it. So here, oops. All right. Okay, so here's an example of an interactive plot, and you can yeah, here we go. So you can use sort of interact activity here. So use the mouse to select a bunch of points, and you can see underneath the console has changed to reflect that. So using this sort of interactivity, you can build quite nice interfaces for scientific applications. I'll show you a couple of other examples. This shows the traits editor. So traits is a package from Nthought, which is yeah. In fact, they're basing their whole tool chain on traits. It's interesting. So this shows what you can do. For example, this is read interactively, so I could have that as sine x, times x, rerun it, and this changes on the fly. So this is a nice little example as well of what you can do, and these little UI widgets. So if you ever need to produce some kind of tool for interactive exploration of data like this, then you can use these tools to do that. I guess I'll wrap up there, and I'll. Do I have anything else to say? No, I don't. That's it. So I'd be very happy to take questions, and thanks very much for being here.
Does anyone have any questions?
Thanks, Ed. Just about pandas, is it kind of becoming a deeply integrated into the scikits stuff as well, and is like the scikits.learn package?
Not that I've seen yet. It may be, but I'm not aware of it.
But from the impression that you got from the SciPy conference, it's rapidly becoming a first-class SciPy citizen. Would you say?
So from what I've seen, I wasn't actually at the conference. I've just been watching all the videos I can. I didn't see anything with that, so I can't really comment there. Yeah, it's probably just a matter of time. Yeah.
So thank you for the IPython demo. I thought that was really cool to see Python run in the browser and see the results in mathematical notation as opposed to monospace. That was really cool. But I presume that was running on the server side. How does that? Is it secure? Can you just type in anything?
Yeah. Yes, by default. But by default, it's not exposed on outside the local loopback interface. But yeah, there are some security kind of features that IPython has. It's designed to be run on clusters. It's a really good tool for parallel processing actually, and so there are some features that can help. I wouldn't advise running one on the public internet at this stage. But having said that, there are some nice innovations like Amazon AMI images with a complete Python stack and an IPython notebook, which are accessible on the cloud. And so that kind of thing is happening now. And so I think someone's talking about PyCloud later as well. That's something like that, a little bit older, but the same sort of principle of having a complete stack of Python tools accessible in the cloud. But yeah.
Cool. I actually have a question.
Yeah.
When you were using Python to optimize that demonstration you had, you used the time it function. Was that poisoned by the fact that it had to compile it? Was it timing the compile in there as well?
That's a good question. I don't think it was, because otherwise it wouldn't have been as fast as it reported. So it reported like 500 nanoseconds per loop. So I think it's just a guess, but I'm thinking it's that's been factored out. Yeah.
Any more questions for Edward?
Yeah, I'd be very happy to talk to you afterwards as well. So yeah, thanks. Cool.